Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. How many ways can 6 different video game cartridges be arranged on a shelf? This item was already solved using the fundamental counting principle, but this time we are going to establish the process of permutation in order for us to use that in similar situations. We know that for our shelf, all the 6 video game cartridges can be placed on that. In short, we were able to use the fundamental counting principle using 6 different slots, 1, 2, 3, 4, 5, and 6 from last time. But we will not be using that this time because we are going to use here the permutation in this formula. NPR is equal to the n factorial over, you will have the difference of n and r. Then whatever the result, you have here your factorial. Now what are the requirements before we could really use the permutation, and why is it that we choose this video or this item aside from the other items with already video discussions? We can only use permutations with these 2 different concepts. Number 1, there should be no repetitions. Of course, once you place a certain video cartridge in the first placement, it can no longer occupy the rest of the placements. That is why there's no repetition here, there's no replacement, and we are sure that once a cartridge has been placed on a certain placement, it can no longer be occupy the others. Now, aside from that, before we can use permutation, need to understand that if the arrangement of, in this case, cartridges are counted differently if you're going to interchange just 2 or 3 placements. So for example, you will have here red, blue, yellow, green, orange, and purple. Once you will interchange red and blue, even if we have the same type of cartridges, they are counted differently, hence they are counted twice. Those are the 2 conditions before we can use our permutation. Now here, what is our n? Our n here is the number of objects. We have actually 6, okay? 6 placements or 6 objects, and we are going to take how many of them at the certain time. Since there's no other specification here, and we are quite sure that for this given situation, all the 6 cartridges can occupy on a shelf, that would mean we are taking 6 of them at the same time. Okay, so we have 6 taken, 6 here. This would be in the formula 6 taken, a permutation 6. So using this formula, you will have here 6 factorial to be divided by 6 as our n minus 6 as our r, and you will have here factorial. Do you think that our denominator would be 0 and this would be entirely undefined in terms of real numbers? Let's check that later. Now let's talk about n factorial. Just a short review. N factorial means the product of all integers n in descending order. So you have n times the number before it, n minus 1. So in this case, if it's 6 times 5, then n minus 2 times 4, until you reach equal to 1. You'll be multiplying all of them. In short, for our 6 factorial here, that's actually 6 times 5 in descending order times 4 times 3 times 2 and then times 1. So we are multiplying all of these integers because we're talking about factorial. Then our denominator is in this manner. 6 minus 6 is 0 factorial. Okay. What is the value of 0 factorial? Is it equal to 0 itself? The reason why I also chose this item, even if this was already solved from last time, aside from the fact that this captures the idea of permutation, is that for us to analyze or be familiar with 0 factorial. 0 factorial, when we use this kind of concept, of course, the product of all integers, that would be 0. But this is a special type of factorial notation because 0 factorial is always equal to 1. Okay? Even if, again, it can be structured as 0 times 1, etc. There might be a separate video discussing only the reason why 0 factorial is equal to 1, but in this case, it's equal to 1. In short, our denominator is just equal to 1 itself. Okay, so I'm just going to take that again, it's equal to 1. That would mean the number of ways for 6 different video game cartridges be arranged on a shelf would be the product of 6, 5, 4, 3, and 2, and 1. So 6 times 5 times 4 times 3 times 2 times 1. The result here, the number of ways we can arrange the 6 different video game cartridges on a shelf would be 720 ways, or 720 arrangements. Again, in permutation, the arrangement for even if we are interchanging the cartridges, they are counted differently. Now, this answer is similar to the previous video using fundamental counting principle. Let's use that here. Of course, in the fundamental counting principle, we know that there are 6 cartridges that can be placed here. For the second placement, since 6 is or 1 is already occupying the first placement, there would only be 5. Then we have here 4, 3, 2, and 1. And similarly, we can see that this is just equal to the numerator of the formula of permutation, which of course gives us the same result, 720 arrangements. So this is how we use the concept of permutation. Once we have established the conditions, we just simply have to determine the number of n, number of total objects, and how many objects do we take at a certain time. Use this formula in a little bit help of our calculator, you will get 720 arrangements. And that's counted in. Talking about getting the luck of the draw. For all in, subscribe now.